Hello students, in this video we will solve one example of Fourier integral representation. So example is find the Fourier integral representation of the function f of x equals to e raised to ax for x less equals 0 and it is equal to e raised to minus ax for x greater equals 0, where e is always a positive real number, and also show that integration 0 to infinity cos of lambda x divided by lambda square plus a square d lambda, this integration is equal to pi upon 2a e raised to minus ax for x greater equal 0. So first we have to find its Fourier integral representation, and then we have to show that this integral is equal to pi upon 2a e raised to minus ax. Alright, so first thing we'll see nature of our function. So here f of x is e raised to ax when x is less equal 0 and e raised to minus ax when x is greater equal 0. So let's check its nature. That means we will check whether it is even function or whether it is an odd function, because if it is even or odd, we'll have easier formula to find its Fourier integral representation. So for that, so to check even or oddness of the function, what we do, we replace x by minus x everywhere. So this will become e raised to minus ax for minus x less equals 0. Even in the interval also we have to replace x by minus x, and it is equal to e raised to ax for minus x greater equal 0, but which is same as, now you can see here minus x is less equal 0, that means again, so this is e raised to minus ax for x greater equal 0, and it is equal to e raised to ax minus x is greater equal 0, that means x is less equal 0. So you can observe here this is same as the original function. Whenever x is less equal 0, function is e raised to ax. Same thing here. For x less equal 0, it is e raised to ax. For x is greater equal 0, it is e raised to minus x. You get here, for x is greater equal 0, it is e raised to minus ax. So what we understand from this, that f of minus x is equal to f of x, right? This implies f of x is an even function of x. Okay, now next is, because it is even function, we will find its Fourier cosine integral representation. So for that we have to find its Fourier cosine transform. Therefore Fourier cosine transform of f of x is, so we call that as fc of lambda, which is equal to integration from minus infinity to plus infinity f of u. Okay, as we are finding Fourier cosine transform, the limits are from 0 to infinity. F of u cos lambda u du. So which is equal to, now put this f of u. So between 0 to infinity, what is our f of u? That means when x is greater or equal 0, f of u is, so you can see here, for x greater or equal 0, f of u is e raised to minus x. As we are integrating between 0 and infinity, therefore that means x is greater or equal 0, so f of x is e raised to minus x. Therefore f of u will be what? E raised to minus au cos lambda u du. So which is equal to, now here we will use this formula. The formula is integration of e raised to ax cos of bx dx. So this integration is equal to, it is e raised to ax upon a square plus b square into bracket a cos of bx plus b sine of bx. So we use this formula of integration to evaluate the above integration. So by this formula you can see here our a is nothing but minus a, correct, and b will be lambda. So a is minus a and b is lambda. So by using by this formula we get fc lambda is equal to this is e raised to minus au divided by a square, that is minus of a square will be a square plus b square, that is lambda square, into bracket a. So our a is nothing but minus a, that means minus a cos of lambda x plus lambda sine of lambda x within limits 0 to infinity. So which is equal to, now when we put upper limit, it becomes e raised to minus infinity upon a square plus lambda square plus into minus a cos of lambda into infinity lambda sine of lambda into infinity. Just a minute, there is one correction here. In place of x it is u. Our variable here, while integrating, we are integrating with respect to u. Okay, so minus e raised to 0 upon a square plus lambda square into minus a cos of 0 plus lambda sine of 0. All right, now you can see here this e raised to minus infinity will become 0. It is 0 minus e raised to 0 will be 1, and this is cos 0 will be 1, sine 0 will be 0. So this is minus a. So what we get here is a upon a square plus lambda square. So this is what our fc lambda is, Fourier cosine transform of given function. All right, so now we have fc lambda and therefore Fourier integral representation is that is, we have to put this epsilon lambda in this formula. F of x is equal to So as we have used Fourier cosine transform, so to find f of x again, we have to use inverse Fourier cosine transform. So by inverse Fourier cosine transform, we get f of x as, so it is equal to f of x as 2 upon pi integration from, okay, so this integration will be again from 0 to now infinity, because we are finding inverse Fourier cosine transform, into fc of lambda, which is a upon a square plus lambda square e raised to, so no, sorry, a upon a square plus lambda square into cos of lambda times x d lambda. All right, so this is what Fourier integral representation of given function f of x. So this is how we have expressed that given function f of x in the integral form. Okay, so this is the first part of our example, and the second part is we have to show that the equality. Now see, what is f of x? So we know what is value of f of x. So f of x is what? Now f of x is e raised to ax for x less equals 0 and e raised to minus ax for x greater equals 0, and we have to show that equality for x greater equals 0. So therefore when x greater equals 0, f of x, which is e raised to minus x and which is equal to, by above integral representation, it is 2 by pi 0 to infinity a upon a square plus lambda square cos of lambda x dx, okay, for some a greater than 0. So now put a is equal to 1, then we get a required equality, which is 2 by pi integration from 0 to infinity. Because a is 1, we'll get cos of lambda x upon 1 plus lambda square d lambda. Okay, all right. We have to prove not for a is equal to 1. Okay, this was, so here was our final answer actually. Okay, we have to prove this equality for general value of a. All right, so instead of substituting a is equal to 1, so it is not required, we can just simply rewrite it and we'll get the answer. So this implies, so just, okay, this is e raised to minus ax, you can take this a outside, to a upon pi integration from 0 to infinity cos of lambda x divided by a square plus lambda square into d lambda. There is one more correction here, this is integration with respect to lambda. So when you are using this, when you are solving examples of Fourier integration, Fourier transform, be very careful about the integration sign, okay, with respect to which variable we are going to integrate. So now we are integrating with respect to lambda. So this implies integration 0 to infinity cos of lambda x upon a square plus lambda square d lambda is equal to pi upon 2a e raised to minus ax for x greater equal 0. So this is what we are supposed to prove. Thank you.